We've been looking at parallel lines and the angles that you get when you've got them and you've got a line that crosses them, and that was the transversal. We looked at corresponding angles and they look like an F. Though sometimes the F is backwards and sometimes the F is upside down, but it's still an F kind of shape. Same deal with these alternate angles. If you're looking on the opposite side of the transversal, you get something that looks kind of like a Z or a backwards Z. That's the kind of shape you've got. Yeah, I suppose it's a bit like a lightning bolt. Shh. Now, the final kind of relationship that I'm interested in is this one over here. Okay, now we keep on coming back to AQR, right? I want to compare AQR and QRC. AQR and QRC. Now look at them with me. Look at them with me. Clearly, they are not equal, right? I mean, I could try and draw them so they looked equal, but on this example, this angle up here, it's a blunt-looking angle, right? What's the name for a blunt-looking angle? Starts with an O. It's obtuse, isn't it?
A blunt angle.
And obtuse literally just means blunt, whereas this angle down here, right, is not blunt at all. It's quite sharp, which is why we call it acute, right? Have you ever noticed when, like, if you're reading like a pack of Panadol or something like that, it's like, for acute pain, you should da 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 da. It means sharp pain, okay? So this angle is obtuse, this angle is acute. They are not equal at all. But they must have some kind of relationship, right? So here's what I want to look at. We've already established that AQR is equal to QRD. Yes? What was the reason? What did we call them? Yep, what's up?
Alternate.
Good. They're all opposite sides of the transversal. They're alternate. Okay? So I can say angle AQR is equal to angle QRD because they're alternate. Okay? And if I had time, I would write out that reason. Okay? But look with me at, let me get another color, these two angles together, QRD and QRC. QRD, there's one on this side, right? And QRC on the other side. Okay? Now think back to when we first started looking at angles. These two angles are related to each other. They're not vertically opposite. They're next to each other, so we give it a slightly different name. Do you remember what we called them? Adjacent. They're adjacent angles. They're not just adjacent though. They're adjacent along a straight line. Okay, can you see that? They're adjacent along CD. So therefore I can say that these two angles, they add up to something. What do they add up to? Ash? 180 degrees. Angle QRD plus angle QRC. They add up to a straight angle, which is 180 degrees. Okay? But look. AQR and QRD are the same, right? They're the same. So therefore, in this next line here, instead of writing QRD, I'm going to write AQR, because they're the same. They're the same, okay? So when I add that to QRC, which is the angle that I was interested in, it should still equal 180 degrees. Right? Can you see that? Is that all right? Let me write down, this reason's important, by the way. You should probably have this one down. The reason why they add to 180 degrees is because angles on a straight line. And on the straight line is CD. Add to 180 degrees. Okay, please have that written because, like I said, the reason is the important thing. Okay? So therefore, from there, I conclude that I can make that swap, that substitution between these two angles because they're the same. No.
That thing before AQR that shows like it's an angle. It really throws me off. It looks like an L.
It does look like an L, doesn't it? So what I would recommend is you make sure you write it at enough of a, like, don't write it like this.
Yeah.
So it looks like an L. Okay. Now, don't go anywhere yet. I told you we ran out of time. This is why, right? I'm gonna finish this off. These two angles here, right? Have a look at them. they're both inside this little box here, right?
Yes.
They're both inside. So the phrase we use to say they're both inside is this phrase. We call it co-interior angles. Because they're both inside. Both inside. So if you look at the shape that they form, it looks kind of like this. Kind of looks like that. See how they're both inside? Right? But they're not the same. They're not equal to each other, are they? What are they? They're supplementary. Corresponding angles. They look like an F. Okay? If you turn around the co-interior angles, they look kind of like a U, right? Right? And those alternate angles, if you turn them around, they kind of look like an M.
Yeah.
Angles are fun.